All right, we're going to talk real quick about velocity and two different ways to think about velocity. But before we do that, we have to talk about time, because when you say time, everybody says, oh, like the time for this, or the time for that. Like time is different than what you're actually saying. So when you say time, what you're really talking about is elapsed time. So when we talk about elapsed time, what you mean is a time interval, right? So when you say the time it took was, 20 minutes, you don't mean at 20 minutes. You mean from 0 to 20 minutes, right? So you mean a span of time. So when we talk about elapsed time, we talk about delta t. You'll see delta t in a lot of the equations we use. We always usually assume you start timing at 0, right? But sometimes a problem you solve may not start at 0. Like something may do something at 5 seconds, right? So then you would look at the final time, maybe 20 seconds, and you would subtract the initial time, maybe it started at 5 seconds, for the time interval of 15 seconds, right? So that's what we mean when we look at these equations and you see delta t in it, right? Not an instant in time. We mean a time interval. Okay, so let's talk about the two ways to think about velocity. So first off, we already know that velocity is displacement over time, right? Again, time interval, but we just call it time. So when you look at this, this is actually the average velocity. And so sometimes you'll draw a little bar above it, but we just use the average velocity as the velocity because a lot of times we're dealing with something that's going some uniform acceleration or some uniform speed. And so it's not changing like something in real life would, right? So delta x over delta t is going to be the average velocity. And there's another way to think about it, and I'll show you why it's important. So let me draw an example, right? Let's say you go from San Antonio to Houston, right? So Houston's over here, and look, you're in a car, right? There's your terrible car. You went to Houston, and let's say the distance to Houston, it's about 200 miles, right? Depends on where you start. Okay, and let's say it took you 4 hours. If you ever driven from here to Houston, 4 hours is a long time to be on the road, right? It usually doesn't take that long. So if you drove San Antonio to Houston 200 miles, 4 hours, your average velocity, or just your velocity, is going to be the displacement over the time, right? And so your displacement was 200 miles and your time was 4 hours. So that means your average velocity was 50 miles per hour east, right? Because we're talking about velocity. Okay. So if you've been to Houston, you know that's pretty slow, right? Normally, if you're saying you're driving 50 miles an hour, something must have happened, right? So what if your average speed, it took you 4 hours to get to Houston, you went 50 miles an hour, right? Did you just drive slow? Did you get stuck behind some trucks? Did you break down? Did you stop somewhere along the way, right? So we can know more about what happened at your trip if we shorten that time interval. So let's say I measure how long it takes you to get to, Luling. And then I measure how long it takes you to get to some other point, like, I don't know, Sealy, whatever, right? So one of these little towns, right? If I start measuring how long it took you to go this distance and then this distance and this distance, I'll get a better idea of how you were moving in those points. So maybe you weren't traveling 50 miles an hour the whole time. Maybe you stopped somewhere, right? So if you take this down to the logical minimum, if I make that time interval as small as possible, the time interval would be like the blink of an eye, right? That's the smallest possible time you can think of, right? So the blink of an eye, that time interval being that small, that'll tell you your speed at that moment in time. And that's basically what your speedometer is. Your speedometer is telling you how fast you're going at the instant in time that you look at the speedometer. Okay, so that's what's called your instantaneous velocity. If you want to know how fast you're going at a specific moment in time, so not over some interval, but at that moment, that will be your instantaneous velocity. It's that velocity at a specific point in time. And that's how fast you're going every time you glance down at your speedometer. So we can see this a little bit better if we graph this motion. So I just said you went from San Antonio to Houston, but let's say the graph of position versus time, right? So this is in miles and this is in hours. Let's say that graph looks something like this. Here's your position versus time graph, right? So you can see this, you didn't just drive 50 miles an hour straight to Houston. Something happened here in the middle, right? So what happened was you drove pretty fast and then you stopped for a while. Maybe you stopped at Buc-ee's, right? And then after a while, you spent a long time there apparently, right? You like beaver nuggets. And then later on you left and you drove fast again and you ended up at Houston, right? So this is showing you a more complete picture. So if I want to know how fast you were going here, right? If I take this point right here and I find the velocity at that point, let's say your instantaneous, right? Instantaneous velocity at that point, let's say you were going 70 miles per hour. And let's say over here you were also going 70 miles an hour. Those are your instantaneous velocities. But here, your instantaneous velocity at this point right here, right? Your instantaneous velocity was 0 because you stopped there. You were over at Buc-ee's, okay? Those are instantaneous velocities, just the slopes of those lines everywhere. If you want the average velocity, this number, what that number was taking here, right? So this is your initial time, and then right here is your final time, right? And I'll do this in a different color. So you started here, you ended here. So if I do that, what you're getting is a position time graph that looks like this. So your average velocity, this yellow line, is what was 50 miles per hour. All right, so you can see you get different information depending on whether you want to look at instantaneous velocity or average velocity. Instantaneous is more focused on a specific point. So let's look at one more example, right, with a different graph than this. So let's say, I don't know, you have something, you're in a car, right? Position time, we'll do this one in meters and seconds. So you're in a car and the car just speeds up, right? So it looks like this, okay? If I want to know my instantaneous velocity at any point on here, right, because velocity is the slope of a position time graph, all I need to do is pick a point and draw a tangent line to this graph, right? Tangent line that only touches one point, and I can find the slope of that line, and that'll give me my instantaneous velocity, right? So here, if I draw a line, see how you can see the instantaneous velocity, it's steeper, but if I go over here and I find my instantaneous velocity, I draw a tangent line that looks kind of like that. It's a little bit slower, right? That's instantaneous. If I want the average velocity between those 2 points, what I do is draw a point there, right? And then I draw a point there, and here's my initial time, and here's my final time. And what you do is you just find the slope of that line. So this would give me my average velocity. If I just did the slope, rise over run of this. Instantaneous velocity, I have to take a specific point, find a tangent line, find the slope of that.